Okay, we're on problem number 3, and what I noticed is they got some a region here, and I'm going to talk about the region first. The region is there's 3 lines, by the way. This, this, and this, and I'll kind of just draw like a rough picture of that. And this first line here is just slope of a negative slope, -1. So it's sort of like this over here. That's relatively simple to do. Y-intercept of 13, slope of going to be -1. This is also pretty easy to draw. X equals -1. What does it look like? I'm going to say something like this over here. I'm just getting a feel for what it looks like. Now, the other thing you've got to talk about is the other line is, it's a slope of 3, positive slope, and a y-intercept of 9. So I'm going to say, it's a steeper slope, so something like this over here. All right? So right now, I know the region, and the region that they're talking about, this one over here. I want to find all the points I need, though. I need this point over here, and that's where those 2 lines intersect. And those intersect when 13 minus x is equal to 3x plus 9, which means 4x is equal to 4, or x is equal to 1. So this point over here is where x is 1. What would the y be? The y would be 12, all right? Let's do these points over here. And, the point over here is where x equals -1. And what does the y equal there? Well, it's on this curve over here, so that would be -3 plus 9, which is going to be 6. What's this point over here? It's going to be -1. That's what the x is. And what's y coordinate going to be? It's going to be 14. All right? Let me get the eraser out. I'm going to start to erase. I've kind of like traced over these things here. Erase this. I'm going to erase this business over here. And I know my region, right? The region is this region over here. It's a pretty simple region. I see a bounded region. That's good news for me. So what I need to do is I need to do that disk method to do it. And to do that, I'm going to do the big disk and then take away the little disk. And the big disk is going to be, looking at this over here. This will be the big disk over here. All right? That's being revolved around the x-axis like this over here. So let's write this down. I'd like to write the differential down first, and the differential is going to be x, dx. And where's it starting from? At -1. And where's it stopping? At 1. How do I know that? I'm looking at the picture. I'm seeing it goes from -1 to 1. Differential's dx. This is going to be, I just made, I don't know what that happened there, but that does not right. It's 1. So it's going to be pi r squared. Well, what's the radius of that upper curve? It's really 13 minus x. That's squared. Minus the lower disk, minus pi. And again, the lower disk is this one over here. I'm just going to do this over here. And what's that going to give you? That's going to give you what? 3x plus 9 squared. I think you know by now a variety of ways of simplifying the integrand, but I'm going to say the first thing I would do is probably just factor out pi. And then get -1, 1. And then I see a difference in perfect squares. I can put this on the side for you. It's 13 minus x squared minus 3x plus 9 squared. So it's like, say, a squared minus b squared. So what do you get? You get 13 minus x plus 3x plus 9. Then you would get 13 minus x minus 3x minus 9. What does that give you? Let's take a look at that. You get 2x here. 13 and 9 is going to be 22. Let's see what you get over here. I'm going to say 13 minus 9 is 4. And minus 3x minus x is minus 4x. I'm always, looking for something that makes my arithmetic easier. And I'm going to factor this now. So 2 comes out, and you get x plus 11. And a 4 comes out from this, and then you get 1 minus x. So what do I see there? I see 2 times 4, which is 8. And then I see this times this. So that's going to be x plus 11 times 1 minus x. Well, let me multiply that out for you. What do you get there? you get x plus 11, because 1 times x is x, 1 times 11 is 11, minus x squared, minus 11x. Well, I'm going to write this down. You try to be careful about it. It's 11. And then what do you get? You get, let's see, minus 10x. And then you get minus x squared dx. All right, I know I did a little side work. I'm going to erase it. It's a kind of distraction on them. Whether I'm right or wrong, it's still a distraction. I'm not going to look at that again. I'm going to get rid of my graph. I'm really kind of done with the graph. And I'm really wondering, was I able to meet my first milestone? And that's it. Did I get the proper integration down? Let's take a look at it. I got that. I got this. I got this part. And I got the dx. All right? The next thing I noticed, I noticed they simplified this over here, but, I pulled the 8 out. They didn't pull the 8 out. And I said, I did the key, by the way. So I'm going to say, I got that right, too. I want to do my integration now. And that looks like it might be tough, right? Let's write this down. I'm going to write down equals 8 pi. That's going to be 11x minus, well, you're going to get x squared now over 2, and 2 goes into 10 5 times. Then you get minus x cubed over 3, limits integration from minus 1 to 1. Let's put this down, 8 pi. And I'll put the 1 down now. What do you get? 11, because 11 times 1 is 11. Minus 5, minus 1/3. Minus 8 pi. I'm going to plug in minus 1 now. You get minus 11. Then you get, let's see, minus 5. And then you get plus 1/3. All right? I'm going to factor out 8 pi. And I'm going to start doing the arithmetic. 11 minus 11 is 22. Minus 5 minus a minus 5, 0. Minus 1/3 is minus 2/3. 8 pi, calm down, would be 3. 3 times 22 is 66, minus 2. What do you get up here? 8 pi times 64 over 3. All right, not much I can do about that, but I can multiply it together. This is 3. This would be pi. I want to go through 8 times 64. 8 times 4 is 32. 8 times 6, 48. 48 plus 3 is 51. So 512. Now, I would say for the most part, setting up the integration is probably the most important thing to do. But I wouldn't discount the arithmetic not being important. To me, it's important. All right. Now, granted, someone says it's all over the place. I'm doing problem 1. I'm doing problem 3. We've already verified I got the right integration. I'm wondering, did I get the right computation now? Let's go back over that and see if I got that. And I do see that, 512 pi over 3. I'm good to go to the next question, which will be number 4. Thank you.